Okay, in this video we're going to discuss a few questions, 4 questions to be specific. So for this particular problem, pressure gauge on a tank registered gauge pressure, which is the difference between the interior pressure and the exterior pressure. When the tank is full of oxygen, O2, it contains 12 kg of gas at gauge pressure of 40 atm. Determine the mass of oxygen that has been withdrawn from the tank when the pressure reading is at 25 atm. Assume the temperature of the tanks remain constant. So in this case, we need to understand first what does this first statement describe. Okay, the pressure gauge, which is this pressure. So initial gauge pressure is 40 atm. Okay, so this one is describe what mean by pressure gauge. A pressure gauge is registering a gauge pressure, which is the difference between interior pressure and the exterior pressure. So this 40 is the interior pressure minus exterior pressure, which equal to 40 atm. So interior pressure is the one that we are looking for, okay, to measure to measure any state of system in a thermodynamic system, or the pressure that we always use in a thermodynamic system is the interior pressure, is the pressure of the system itself, okay, not some correction pressure. Okay, this is a correction pressure, basically just to zero the gauge pressure whenever we are at the atmospheric pressure. So this is what we're looking for. So the interior pressure is equivalent to 40 atm plus exterior pressure. So what is the exterior pressure? So exterior pressure is a pressure where the gauge pressure will reach a zero pressure. In such way, if the interior pressure is equivalent to the exterior pressure, then the gauge pressure will register a zero pressure. Okay, so this 40 atm is not the absolute pressure. So the interior pressure is the absolute pressure. So the absolute pressure, because we always need the absolute pressure, so the absolute pressure is 40 atm plus the atmospheric pressure, which is 1 atm, does give you 41 atm. So the same thing for the final. So this is initial. So P final, the absolute pressure is 25 atm plus 1 atm. Okay, so what we're dealing here, so when the tank is, so initially the condition is the tank is at the 40 atm pressure, and it consists of 12 kg. So if we refer to the ideal gas, so we assume that this is an ideal gas condition. So PV equal to N RT. So this is what we're very familiar with, but here given to you is kilogram, so we need to know what does the kilogram with the N is related, which is N equal to M divided by this molecular mass, which is in this case is the air. It's not given here in this question, so how could we determine this N value? So it doesn't matter, we can just rewrite in this case first. So we need to write down P1, because we know that the P1 there's a changes between in initial and final. V1 Okay, just put it that way first. And n, we need to put it n to be n1 as well, because n is related with the m here, where else it said that some of the gas is withdrawn, okay, withdrawn from the tank, so there will be changes of mass, thus changes of mole as well. So R, we don't need to determine any one or two, so T1, just to make it clear, we just put it T1. Okay, although there is a constant, we just put it that way first. So we will have the counterpart of the final condition. So okay, try to put everything that is similar, so at one side, and the one that is non-similar to the other side. Okay, so in this case, T1 and T2 are equal. The volume of the tank also remain the same, which is V1 equal to V2, and we have this R is equal. So I didn't need to write those. So P1, so I just rewrite back all these two equations. So P1, yeah, we need to put n to the other side, so n1, and then this right side will be R T1 over V1. Okay, remember why we put it all this together, because R is constant, T1 also constant, and V1 also constant. So if you rewrite the second equation, which will be P2 over N2, which is exactly the same as here, R T2 V1 V2. Okay, since that both of these equations are the same, then we can rewrite as P1 N1 equal to P2 N2. Also, another way you can say that in a final, initial over initial equal to final over final of these values. Okay, so again, we don't have this n value, we need to change with that, so we just have this equation transformed to in the form of that. So P1, so m divided by, so m1 divided by m1, so P2 m2 divided by m2, and then since that these two are, this m and m2 is equivalent because it's the same component, which is the air, so again we can cancel both of these, thus reduce the equation into P1 m1 P2 m2, so that we are helping us to determine the value. Okay, so what we are going to look, we already have m1, which is the initial, m2 which we don't have, so m2 will be equivalent to P2 P1 times m1. So what is the pressure of P2? So P2 is the absolute pressure, P1 also the absolute pressure at the time, so P2 is 26, so we can have both of them remains at the ATM, because both of them are in the ATM value, and the ATM to the Pascal is a conversion to decimals. That's why we can just retain the units. So this is 41, and then this one will be 12 kilo. Okay, so what you get is 7.61 kilogram. And remember, the question asks you the mass that have been withdrawn from the tank, so which means that the change of mass, which is 12 kilogram minus 7.61 kilogram, does give you 4.39. So this one should be, which changes should be the other way around, which is the initial for the final, which is the final is 7.61 minus 12 kilo, which give you negative of 4.39 kilogram.